All right, so today starts day 4 of our end of course exam review. Okay, the EOC review, day 4. We're going to do exponents, scientific notation, and systems of equations, and then we'll go back and finish 25 and 35. All right, so it's going to be a pretty full day. Number 41, we have a to the 4th power times a to the 6th power. Well, I'm going to divert down here, and I'm going to give you another one before we solve that one. 2 to the 3rd power times 2 to the 7th power. What I notice here is that I have the same base, and what my rule says is when I have the same base, I can do what to my exponents? Add them, 2 to the 10th power. All right, so let's go up. What would a be? A to the 10th power. Okay, now something different happens on number 42. Now, I'm going to stick with my 2's that I just made up. If I had 2 to the 3rd power raised to the 7th power, something different is now happening. I only have one base that I am raising to a power and then another power. Caleb, do you remember what my rule is when I raise a power to a power? Yes. What do? You multiply. Yes, so what would it be? It's 2 to 21. To the 21st power. So, Ashley, what would number 42 be? No, number 42. So, we go power of powers. So, what would I get for number 42? Jeremiah? X to the 24th power. X to the 24th power. Very good. All right, now on number 43, I have, what does a fraction mean? What operation? Division. Okay, so I use my common base of -5, needs to be in parentheses, but now I'm subtracting the numerator minus the denominator. So -5 to the 5th power. -5 to the 5th power. On number 44, I have what? What do you see here that's a little different that I probably have to take a look at before I can solve? Just tell me. Well, yeah, I have to evaluate it. I know, but what do you see, Robbie? The negative exponent. I cannot evaluate a negative exponent. But I can't just erase it because I don't want it to be there. Okay? What is my rule for changing a negative exponent to positive? I don't want you to say it yet. I want to see how many of you can remember. How do I make a negative exponent positive? Sam? Why would I put it over 1? What is it now? What is it in now? It's in a fraction. Because my rule says that what can I do with it, Sam? Flip it. Put it in the opposite side of the fraction. And now it becomes positive. 1 over 3 to the 3rd. So what if it had been in the denominator to start? Where would it be now? In the numerator. Okay. So, Jakari, what would my answer be? What is 3 to the 3rd power? 3 times 3 times 3. Anybody help him out? What is it, guys? 27. 1 over 27. Okay, next problem, number 45. We have 3x to the -4th times 4x to the -9th power. I need to evaluate this, but then my answer has to be using only positive exponents. I'm going to go ahead and walk around and check on you guys and see how you're doing on this problem. Check on your group mates too. If you think you got the right answer, see how they're doing. 3 times 4, guys. We just said it. Oh, come on. What's 3 times 4? 12. Thank you. 12x to the -4th plus -9. What's -4 plus -9? 12x to the -13th power. So let me ask you this. Does 12 have a negative exponent?
Yes, it does.
12 does not.
No, it doesn't.
12 has an exponent of an understood 1. 12 is separate. It's independent from the x. It's being multiplied by the x. So if I need a positive exponent, I leave the 12 up top and I move x to the 13th to the bottom. Now, I did have a couple people from the beginning move the x's into the denominators and then they added them. That's fine. It's still in the denominator. And then they added their exponents. All right, look at number 46. Go ahead and write your decimal value. Remember, your decimal must be greater than 1 and less than 10 and be multiplied by a base of 10 raised to a power. Go ahead and do 46, 47, 48, and 49. All right, guys. Okay, so scientific notation. Guys, pay attention. Scientific notation. I go 4.3. Oh, hold on. Oh, goodness. Hold on. Here we go. 4.36 times 10 to the what power? Nope. 10 to the 10th power. Who got that right? Raise your hand if you got it right. Pay attention. Okay. Number 47. 4.35 times 10 to the what, guys? Is it to the 7th power? It is the negative 7th power. All right. Number 48. Did you put 3 zeros? 5, 6, 4.
Yes.
Number 49. How many zeros after the 8? How many zeros after the 8? 7. Because you have to move it 9 places. You already have 2, so you need 7 more zeros. You need 7 more zeros. Now, on this last one, and I did this on purpose, it is very similar to your EOC problem. So what operation do you have here and is most likely on your EOC? Addition. Okay, so it's addition. So the next thing I need to check for, and the way that I explained this to you when we learned this lesson is, it's just like a fraction. You can't add fractions without common denominators. You cannot add numbers in scientific notation without a common exponent. Do I have the common exponent? Do I have a common exponent? Yes, I do. So because I have the common exponent, I can add my decimals together. Go ahead and do that. Add your decimals together and keep your common exponent. What's 4.8 plus 6.2? 11. Okay. Someone tell me why this is not my answer. Why is this not my answer? Nope. You keep the common exponent. Nope.
The 11's bigger than 10.
All right, so I saw Milani got it, okay? So, yes. Did anybody else catch that? Okay. So, but that's okay. So, it's bigger than 10, which it can't be. So, what does it need to be? So, I need to move the decimal, but what happens to my exponent value?
It goes up to a 6.
Does it go up to a 6 or does it go down? I know, and I really had to rack my brain too on it. Okay, if I move it left, so we move it 1 to the left, and we are going to increase the exponent to 10 to the 6th power. And I am going to go back and double check that, but I'm pretty confident that I messed that up last hour. Okay, so yes, move it to the left, and then you increase your exponent to 10 to the 6th power. All right, so now we are going to go back, and we're going to start systems of equations. So that starts on number 28. We're going to go back to 28. We're going to do those 3 problems, 28, 29, 30. Then we'll go back and do number 25. To solve a system, look, pay attention. To solve a system algebraically, what it's saying is use any one of your 3 methods, which I've written up here. Pay attention, okay? You can use graphing, you can use substitution, or elimination. Well, we are not going to use graphing for multiple reasons. One, we would have to get both of these equations in slope-intercept form to graph it. That would be a pain. And then there's too many just things that can go wrong on the graph. So my 2 options are substitution. Well, with substitution, one of these equations has to have x or y by itself on one side. So substitution is not really practical unless I have to use it. The other option is elimination. Okay, hold your questions for just a sec. So with elimination, you need to find either it's the x's or the y's. Are there numbers that are divisible by each other? Meaning I could multiply it by a number to make it the opposite of the other variable. Does anybody see either the x's or the y's that one could be divided into the other one? Faith? It would be the 3 and the 9, okay? So for the 3 and the 9, what could I multiply -3 by to make it the opposite of -9? No. I need it to be the opposite of -9. What can I multiply -3 by? -3. Do you agree that -3 times -3 is +9? So you want it to be the opposite of the other one, but now you have to multiply the entire equation by -3. So what's -3 times 7y? -21y. And then what's -3 times -16? +48. Now rewrite your second equation. -9x plus 5y equals 16. And now you're going to add everything. Okay, well, 9 plus -9, that's what I needed. I needed them to cancel so I can just solve for y. What's -21 plus 5? -16 y. And now I need to add my numbers. What's 48 plus 16? What's 48 plus 16? You have to add them. 64. So now, easy step here, what do I do to solve for y? Divide by -16. Y equals -4. This is the first part of your answer. Remember, your answer is an ordered pair. There's some ordered pair that can be plugged in to both equations to make them true. So I know now that the y value will be -4. Well, how could I find x? Now that I know the y value, how could I find x? Does anybody remember, Robbie? And Faith, does it matter which equation I use? No. I can use either one. Now, I used the one on the bottom purely because I have room to work below it, okay? So if I plug in -4 here in for y, what's 5 times -4? -20. So does everybody see how I got -9x minus 20 equals 16? You see how I did that? I just plugged in -4, and 5 times -4 is -20. Okay? Now I just need to solve a two-step equation to find x. Go ahead and do that. All right, Sam, what would I do now? What would I do now? Yes, add 20 on both sides. Is that what you said? Okay, all right, add 20 on both sides. Aaliyah, what would be my last step?
Divide both by -9.
Yes, divide both by -9, and x equals -4, and that is the other half of my answer. All right, good job. Okay, so now on number 29, it says determine the number of solutions. Well, how many solutions did I have on 28? 1. One ordered pair is a solution. Or is it no solution or infinite solution? So what you're going to have to do on 29, and I want you to talk amongst yourselves, are you going to use substitution or elimination, and then start that process of using that method to solve? Technically, you can use either method. In my opinion, there's one that's going to be easier than the other based on the values we're given. Aaliyah, what did you multiply the top equation by? 2. She multiplied the top equation by 2 because when she did that, pay attention to this. This is so important. Now it's 4x plus 16y equals 12. Now I rewrite the second equation. Negative 4x minus 16y equals negative 12. So great, my x's canceled. That's what I wanted to happen. But now look what else happens. What's 16 minus 16? 0. What's 12 minus 12? 0. Is it true that 0 equals 0? So this is infinite solution. It's infinite solution. Now, listen guys, this is so important. What if this number had been a minus 10? Now 12 minus 10 would have been 2. And is it true that 0 equals 2? No. So it would be no solution. Okay? All right, so infinite solution. Now let's talk about the graph. I'm just going to walk through the graph with you on number 30 because I need time to get to 25 and 35. Look at number 30. On the first equation, do this with me. On the first equation, where does your first point go? On your first equation. On the 1, and where do you go from there? Everybody participate. Where do you go from the 1? Okay, that was about 3 of you. I would go up 3 over 1, draw your line. Okay, now on the second equation, everyone together, where does my first point go? Down 1, and then where? Down 3 over 1. And I draw my line, and again, this is my complaint with the graphing. It's so difficult to get it exact. I believe your answer is somewhere in the realm of negative 0.5 and 0. If you put 0, 0, listen, if this is what it looks like, I'm not going to deduct on your answer. Just get it as close as you can. It really is going to depend on how straight you draw your lines and where they intersect specifically. Okay? All right, so that's going to be our break on systems. That really covers what you need to know for your EOC on systems. Now let's go back to number 25. What did you do first on number 24? What did you do first on 24? Right, what formula? Okay, so you solved for slope. No matter what, you always solve for slope first when you're writing an equation. So go ahead and do that on number 25. We did it 3 times yesterday. Okay, so go ahead and find your slope on number 25. Do that. Okay, so finding slope, I need to do 6 minus 10 and 2 minus 4. Negative 4 over negative 2 reduces to positive 2 over 1. Okay, so no matter what, I find slope first. And on 24, I looked back to my original pairs and I found the ordered pair that had a 0 for x. Do I have an ordered pair that has 0 for x? No. So because of that, instead of it being a really simple, I just look at the ordered pairs, now I have to use something called point slope form to find my y-intercept. Again, no matter what, I need to know slope first, so I'm done with that. And my formula is, you need to write this down, y minus y1 equals m times x minus x1. Okay? Now, m is my slope that I just solved for. Y, now, you can choose the first order pair or the second order pair. It is not going to matter, but you need to use both numbers from the same ordered pair. I'm going to choose the second one just because it's smaller numbers. That's all I really care about. All right, now, in this ordered pair that I chose, the first number is my x1, the second number is my y1. That's what I plug into my formula. Y minus y1. Does everybody see why I plugged in a 6 for y1? I just picked an ordered pair. Equals m, which I just solved for m. You need to understand slope is your m. What was m? 2 times x minus, what is my x1? 2. And now I need to distribute the 2. Okay, so what is 2 times x? 2x. And what is 2 times negative 2? -4. Okay? Now I need one more step to solve for y. What's my last step to solve for y? To get y by itself, how could I get -6 to cancel over? What would I do? I would add 6 to both sides. Okay? And y equals 2x plus 2. Again, I mean, I go back here, I'm like, oh yeah, you know, my slope is 2, so 2x. But to get this 2 at the end, to get that 2 at the end and to get that number right, I had to do point slope form because the ordered pairs did not have a 0 for x. All right? So on your EOC, if you see 2 ordered pairs that don't have a 0, you're going to be like, all right, you got to suck it up and do point slope. If you see the ordered pairs that have a 0, you should be like super excited because it's way less work. Okay? All right, so number 25 directly is related to number 35. Go ahead and go to number 35. What's number 35 about, guys? Gamer. And what's happening here? He got a new game, right? What does X stand for? How many weeks he's owned the game? What does Y stand for? How many times he's lost? Okay? And yesterday we made a scatter plot. You guys have your scatter plots? So here's what the line of best fit is. The line of best fit says, it doesn't just, okay, here's what it's not, all right? It's not connect the dots like this. Okay, look at how it's like kind of curving. That's not the line of best fit. The line of best fit basically shows us how the data should be trending if it were to follow a specific pattern. So we can see if he's maybe kind of ahead of the curve or behind the curve on how much he's improving on the game. Are you with me? Okay, so what you need to do is you need to write an equation. Well, do you remember what I just told you? When you write an equation, what's the first thing you do? When you find an equation, what's the first thing you do? Find slope. So I want you to pull out the first 2 ordered pairs from the table, write them down, and find your slope. Okay? Write them down and find your slope. 1, 15, and 2, 12. Did you pull those out? All right, so what goes in my numerator to find slope? Say it with me. 12 minus 15 over 2 minus 1. What's 12 minus 15? -3 over 1. All right, so that's the first part of my equation. All right, so that's great. Now, just look back to your table for your y-intercept. Which one is paired with an x value of 0? Which y value is paired with an x value of 0? Oh, that's a bummer. There are no x values of 0, which means that you need to pick one ordered pair from the table and use point slope form to find your y-intercept. Pick the first one so we can all stay on the same page. It's not a big deal. Pick the first one so we can all stay on the same page. Y minus, what is the y1 value from the first ordered pair? 15 equals m times x minus what's x1 from the first ordered pair. All right, now go ahead and finish writing your equation. Okay, distribute the -3. Y minus 15 equals -3x plus 3. Now you just have one more step. Stop talking. Look up here. One more step to get y by itself. What do you need to do to get y by itself? Add 15 to both sides. What's 3 plus 15? 18. Okay? So, based on this equation, this is your equation for the line of fit now. Where does your first point go? On the 18. And where do you go from there?
Down.
No?
Over 1, down 3.
Down 3 over 1. Happens to be on the first point. What does that mean? That means that he's trending exactly how he's supposed to be, according to the line of fit. Now where do I go? Down 3 over 1 again, which just so happens to match the prediction that he's going down by 3 losses every week. Down 3 over 1 again. Uh-oh. What does that mean? That means that he actually lost more games in week 3 than maybe he should have. Okay? Not a big deal. Maybe he just had an off day or something. So what the line of fit is showing me, again, it's not just connecting the points that are already there. It's showing me how the data should be trending. Okay? That's it. So this is definitely something you need to look back over. The last thing we need to cover, guys, how could I interpret the slope of that line? Well, what is the slope? What was the slope? Negative 3 over 1. What did my y value stand for, or my rise? What did it stand for? What did it stand for in the table, guys? What did my y value stand for? Losses. What did my x value stand for? Can someone put that into a sentence for me? This is just like the academics with the absences versus the points. Sam? Guys, hang on. I've got one more thing to tell you. We have a 10-minute break anyway. What is it? Are you paying attention? This is important, guys. Okay, we would expect what?
As the weeks increase, the gamer's losses decrease.
The gamer's losses will decrease. Okay, look at what I'm writing. He will lose 3 fewer games per week. Okay, that's what you should be saying for the slope interpretation. Negative 3 over 1, 3 fewer losses per week.